Hey everybody, this is Larry. This is day 14 of the Leetcode Daily Challenge. Hit the like button, the subscribe button, join me on Discord. Let me know what you think about today's poem. I am, as you can see, back in New York. And today we are going to do 33, 37 total characters in string after transformations 2. Hit the like button, hit the subscribe button, join me on Discord, I think. I don't know. Whatever. I'm still still jet lagged a little bit. I mean, this poem, it's a little bit of a spoiler from what we did yesterday, right? In the sense that it is exactly the same poem, and we kind of expected a little bit. In that, my thing is that the two differences, right? One is the S, and the other is the the one is that the transformation from S is not the same, right? There's a replace S survive, the next right? And then transformation wraps around over, okay? And then also T. And T I expect it will be pretty big, which is 10 to the 9, right? I don't really have a great I really don't have a great way of kind of explaining this problem necessarily, because it's I mean, I wouldn't say it's trivial either, but it is like a very specific, very it's just very specific, and I don't know if it's that practical for competitive. Oh, sorry, not for competitive. Competitive, it's fine, but I don't know that it is. Excuse me. I don't know that it is competitive for sorry. I don't know if it's reasonable for interviews, right? I think that's what I'm trying to say. So I'm trying to find my pen for my drawing. I'll draw it out. So the idea here is that you are able to solve this in a set of linear operations, right? It's kind of a little bit, and there's some leaps in logic that I'm not gonna go over in too much detail because there's a lot of background, and this is linear algebra, and they're just like so much math that you can get into as deep as you want, really, right? But let's just say we start with 3 variables, right? And so instead of A to Z, we just start with A to B, right? So like let's say you have I don't know. Let's just say for initial, we can say A is converted to 3B, or no, I guess this one is the consecutive. So I mean, it doesn't for the purpose of this problem, it doesn't really matter. It just depends on how you set up the problem anyway. But let's say 3B and 1C or something like that. B transforms into and I mean, it's particular for this problem ish, but there are a lot of similar problems that people do, right? So yeah, something like that. It doesn't really matter. I'm just like writing random things. Or anyone wants C, right? So then the idea here is that you can kind of express this transformation as a set of linear equations, right? Which is that yeah. So basically, you're given, say, sorry, I'm a little bit. Maybe I should have prepared a little bit for this, but in any case, you have. Let's just say you have a couple of x's. I forget what I'm trying to remember the notation for these things, but yeah, say x sub a, x sub b, x sub c. Maybe that's a little bit more precise. And then now, let's say for every for every x sub a. Right, so every one of these is equal to. Well, I guess I can use the other way around, right? So how many? So you can say, okay, let's say we have, yeah. So after one transformation, how many A's do we have? Well, let's just say x sub a. Here we just look at, okay, well, there's 2 A's and 1 A, right? And that means that if we have maybe the way that I'm setting up is a little bit awkward, honestly. But okay, let's say we have x sub c plus 2x sub b. Is that right? I think maybe I did it wrong. No, this is right? Because basically this linear transformation is just saying if we have 1 x sub b, we get 2 a's. So the number of x sub a's is equal to 2 previous number of x sub b's plus x sub c, right? So that's your linear transformation. And in more plain English, you say the number of a's is equal to 2 times the number of b's plus the number of c's, right? So that's after one transformation. And you can write that out for all the other ones, right? So x sub b is equal to x sub b is equal to 3x sub a plus, this is fine, 2x sub c, and then x sub c is equal to the number of x sub a plus 3x sub b plus 1x sub c, right? So this is how you set it up, right? And this is how you kind of set up the set of linear equation in which defines one transformation, right? Sorry if this is a little bit, because I usually do these live and this is off my head, so maybe I should have prepared a little bit for this one, only because yesterday I kind of expected this one. But in any case, everything is off my head, so I want to give you what it's like when you actually know all these things, right? In any case, so this is how you set it up. And then if you kind of rewrite this part, and maybe I'll just rewrite it to the left a little bit confusingly, you can say that, so you can rewrite that as a linear equations where, you have x sub b, x sub c is equal to the, and this is a little bit awkward in that maybe I'm not super precise in a way. All right, let me actually rewrite this, hang on. And what I mean by that is just that given this, maybe this is like the previous x sub b and x sub c, right? But okay, so because then now you can rewrite this as a set of linear equations, right? Oops. So this is 0, 2, 1. 3, 0, 2, 1, 3, 1, right? And that is this type, right? Maybe I did that wrong. I always, honestly, because this is a square, I sometimes get this wrong. In matrix. So if I did, then forgive me. I think this is right. I mean, it's one of those things. It's either this or this transformed or transposed rather. I don't know. I'm really bad at this part. But in any case, right? And then now this is one transformation. Well, it turns out that to get two transformation, then you just you can look at this as, if you could say A is equal to, I guess this part is also confusing because I'm using whatever, but A being the transformation matrix and X is just equal to, X's. Then now you can write this as A to the X, say of the previous, is equal to some new X, right? After one iteration. It turns out that because this is multiplying, what happens when you want to do it again, two transformations, right? Well, maybe this should be a transpose then, because that doesn't make sense otherwise. Maybe it still does. I don't know. Either way, what happens if you want? Okay, so I kind of wrote this backwards because, sorry friends, I'm a little bit. I don't know. I just took a nap and woke up. But the reason why this is confusing is I'm not using standard notation enough, and because also, I think A is actually technically in this one. But okay, fine. It's fine. We already defined the variables. But the thing is that matrix multiplication is not commutative, right? So that's where I kind of messed up. What I mean to write is that XA is equal to X of previous is equal to say X of, let's just say X of I is equal to I plus 1 or something, right? Okay. My apologies for kind of, whatever. And then you could kind of put i's and I plus 1 on those things. So they're not the same x, right? X sub a. Okay. But then now what happens if you want to do two transformations? Well, you know what happens after one transformation, which is this. And then another transformation is just this multiplied by a again, right? So then after two transformation, this is just then now is this, right? Because, and you could kind of do it with substitution as well if you like, which is that, x of I plus 1 times a is equal to x of I plus 2, right? And of course that because x sub I plus 1 is equal to this thing, so substitution, this is equal to x sub I times a is equal to x of I plus 2, right? And then now, of course, now you can rewrite this as, okay, well, let's say you have the initial conditions, and then you want to transform t times, then it's just a to the t is equal to x to the t, right? And that's really the idea behind this problem. And I know that this doesn't really strictly apply to this problem because you only won the next consecutive whatever, right? But it's fine, right? Like this applies more generally as long as you set up this set of equations correctly. And here, for this particular problem now, let's say you understand all this, then now for this, you can say that, for x sub a, and it's equal to say x sub a sub I, let's say you want the next two, then it's just going to be the number of x sub b, I minus 1, plus x sub c, I minus 1, right? Something like that. So yeah, so that's basically how you set it up for everybody, and then you just do your matrix multiplication. Oh yeah, and now you have matrix and you have multiplication, and let me actually bring back the thing real quick. And then, so the question is, okay, well, how does that help us, right? Because you have x times a to the t, right? So 0 is equal to some x sub t, right? I think this is actually t minus 1 maybe, but either way, it's not a big deal. It's about off by 1. The thing is that then you're like, okay, well, here we still have to do multiplication t times, right? Well, here is where you can use, what's it called? So apparently some people don't consider it divide and conquer, but I still consider it divide and conquer. But in any case, it's a over t to over 2 times a over t times over t over 2, right? So then you could do this by doing only one operation. And so then now this is dot dot dot, and basically you just do log t number of log t number of multiplications, and that should be good. Yeah. So that's basically the theory behind this problem. And like I said, there's more that you can get into, and I hope that this gives you a taste. And if you do need more understanding, just Google this stuff, I think. But yeah, in any case, then now we need at least two things, right? One is we need like a matrix power function. So we have a matrix, and then you have a power, right? Fine. And then you need just matrix multiplication, right? Yeah, okay. I mean, I'm trying to debate whether I want to write it. I guess it's fine, right? So AB, right? And then after that you just need setup, and that should be good. Yeah. So here, okay, we'll do matrix multiplication first, and you could probably Google this if you're not familiar with it. Yeah, I mean that's pretty it. I'm trying to do it off my head just for but yeah, I think we did matrix multiplication recently though. I think, but maybe I'm wrong on this one. Yeah. Right. This is always tough. something like this, right? And then it's going to be AR times AC, right? I guess this here was fine. And now we just do a loop. Excuse me. Right. And of course, you have to. I guess technically you have to assert that BC is equal to no, AC is equal to BR. Though I guess I don't do BR, but that only matters if you set up the problem incorrectly. At least for this problem, right? And then matrix power, as you know, this is like I said, it's just divide and conquer, right? It's the matrix exponentiation. Am I saying that wrong? Yeah, right. Which is yeah. Okay. So if power is equal to 0, return matrix. No, I guess technically you want the identity matrix. So let's just say power is equal to 1. And then otherwise, then yeah, if power mod 2 is equal to 0, then we just return mod power of matrix power divided by 2, right? So okay, so that m is equal to this, and then return I guess this, we always want this anyway, and then return mod matrix multiply of m, and that's it. Otherwise, we return matrix multiplication of m and m, and then matrix, right? I think the order doesn't matter because they're all the same matrix anyway, but yeah. Okay, so then now we set that up, and hopefully it is correct. If not, we have to go back and fix it anyway. Well, something is wrong because no, this is fine. This is the I was like, I'm missing the recursion somehow, but it's here, so it should be fine. Okay, yeah. And anyway, yeah. So then now we have to set up the array. So we have so we have two things we have to set up. One is the transformation matrix, and then the other is the initial conditions, right? The initial conditions are more straightforward. You could even say it is basically the same as yesterday's, I think, but which is just, you know, right? So that's the so now you have this the initial condition, and then now you have to set up the transformation, which is given by nums. So yeah, so then now we have trans is equal to right 0 times 26 for right. And then now for, I guess, index and x in enumerate nums, because then now it's going to be x or index. No, x is the character. So let's just kind of see. Oh no, that's x is not here. Index is the character. So then now it is going to be trans of index plus x, except for you have to loop over x, right? So plus 1 maybe, depending on how you write the loop really, but yeah, something like this, right? And I think that's roughly it. And then now we have to do the f times trans, and we should be good. F trans. Oh wait, no. Well, I mean, okay, that gives us the final result. And then now we have to sum up. It should give us a thing, so we should do sum. But it gives us a matrix. So it's either sum of all or sum of something like this. But let's run it real quick. And I know that I didn't take care of the mod yet, but I just want to kind of run it real quick, just to make sure that it doesn't. Oh yeah, I did know this. Whoops. You have to mod this, of course, for the wraparound. I was thinking about it and then I just forgot about it. But you know, AC length, object of length int. Oh, because I create this as 1D array. Maybe I should have done it like this. Right. Oh, wait, where is it? Okay. Well, this is right for this one. That's good. This is one which is a little bit awkward. But alright, let's print it out real quick. I mean, I think I rushed through that part, the implementation part, a little fast. This is really not okay, right? Oh, this is I forgot to. I don't know what. Wow, I'm just silly. Okay, t is equal to 1 is y, but yeah, I forgot to matrix power this by t. That's why. And I think technically it is t minus 1, but maybe. Maybe I'm wrong on that actually. But I did power is equal to 1. Why does this infinite? I feel like I am. It does look a little bit different than I'm used to writing it, but okay. Oh, power is equal to 0. Why is power? Oh, okay, fine, right. Then return the identity matrix, which is a weird thing, but and this is just like a regular identity matrix things where you have one on diagonal. I thought I didn't need it, but okay, so I was wrong about t minus 1. But, okay, well, maybe I'm just wrong on a lot of things. T is 2. So we do 2 transformation. That makes sense. So then now, why is this wrong? So t is equal to 2. We have this multiplied by the 1 times 1. Why this isn't print anything? So that's kind of not great with t is equal to 2. Do I change it by accident? Did I shadow anything? No. They should at least print. Oh no, I'm looking at the wrong one. Okay, it does print something, so that's good. Why is it dotted away? That's actually not great. Okay, fine. So it prints 2. Why is this still 1? Matrix. Sorry, friends, technical difficulties. But, did I mess up something else? Alright, let's just try something really quick. Well, it went from 5 characters to 5 characters, but it went... So, yeah, something is definitely very wrong, right? Because I went from 5 characters to 5 characters. Which actually may be right, but there's something really weird because this is the final output, and that is saying that we have 1 character that's all yi, which is not right. I said something else wrong. Clearly, I times j times b times j times k. That seems right. Am I doing it wrong? Maybe I am. Okay. Well. This doesn't seem like it could be wrong. Did I do this wrong? Alright. Okay, so this looks kind of right, except for it doesn't make sense. Oh, did I do the transformation incorrectly? Maybe I did it incorrectly. I think actually technically that's wrong too. What I needed was no, that's not right. Huh. I want to write it like this, right? Nope. How did I write it? Why does this look so weird? Give me like an iterator thing, right? Okay. Oh, I guess just times 1. Okay, yeah, that makes more sense. No, yeah, okay, so before it makes sense. Okay, no. Sorry, friends. This is what happens sometimes when even when you get the algo right, like, you're also going to run into technical debugging things, and hopefully this is maybe helpful. Maybe it's not. Who knows? But yeah. But basically what I'm reading is that this is the final output, and this is saying that we have A, B, C, D, E, we have 1 year after 2 iterations, which is obviously not right, even though the output is right. So I'm trying to figure out, and this is, I don't know, this is wild, but okay. Can T be 0? T cannot be 0. So let's see. I mean, my guess is just that I'm setting up the transformation matrix incorrectly. Like, I don't know how this got adjusted to be that way. Okay, let's say x is equal to 1. Then this is index plus 1. Should be good. Transformation should be good, right? Alright, let's just print out the transformation matrix. Yeah, no, this looks what I want. Is it? No, I think this is right. I mean, unless I did this wrong and I transformed it. No, I think that doesn't make sense. Yeah, that doesn't make sense. But, no, does it though? Because now it gives the right answer. Not for this though. New A is equal to I think I'm just setting up wrong. The idea is mostly right. Man, I think when I did it last time it was right, but I guess not today. But this is not going to be right, because this doesn't check out. Oh wait, did I just do that part wrong? Dumb. Oh, I am dumb. That's why. That is a really bad typo. Because I was always transforming 1 C or X number of C's. Okay. Wow, that is a pretty dumb typo. Okay, so now I don't know. We did all that debugging, but okay. So actually our idea was mostly right. It's just that I didn't see a typo. But anyways, we have to take care of mod, of course. Which is easy to do. I mean, otherwise we would have used like a library or something. But yeah. So the key idea here is that the only thing that we do math is about here, right? So we can probably put this here. You can. It's really expensive a little bit, but I think it should be fine. So yeah, let's give it a quick submit. It may be a little bit wrong actually, but I'm just a bit lazy. And it may be a little bit slow because this gives us so many mods things to do. Oh. I guess I was wrong on the mod. Wait. Oh, because I do. No, I was gonna say because we do a final transformation, but why does that happen? I mean, it's a mod issue, but I'm curious why that is. Because we mod here and it should be fine. Oh, I'm dumb because of the sum. So each cell would be okay, but the sum we have to. Okay, well, I'm just being dumb today. Clearly, I have a typo that I did not think, and then okay, that's just damn it. I mean, it may still time out just because of this thing, and that would be fine. But yeah, 1870-day streak, so we're happy about that. But yeah, I mean, honestly, we wasted about like what 10 minutes of me just like debugging, but like the code was mostly right. Here, what we actually probably want to do is just actually take that outside. It's just that I was too lazy to do it. But yeah, and that should be a bit faster, just a lot fewer mods. Right. Yeah, so you could see that we went from 4 seconds to 2.8 seconds. I guess I didn't do it last time when I did it in the contest. But yeah, I guess I was lazy during the contest. But yeah, actually, the code is mostly the same, really. Anyway, that is all I have for this one. Let me know what you think. Yeah, the complexity you could probably work out, right? This is going to be, this is for the most part like 26 times 26 times 26, right? Which is alpha cube. It's not quite that because technically they all have, we do one more multiplication that is different from that, but it's going to be bound by alpha cube anyway. And here, this is going to be linear in the size of power, right? Which is t, right? Linear because t is represented by the number of bits, so linear in the number of bits is why, yeah, it's how this kind of works out, right? And of course, we have linear number of alpha cube number of operations, right? So it's like O of linear in t times alpha cube or something like that. And that's basically it. And maybe like one more multiplication. We want to do the math on that. But yeah, that's all I have for this one. Let me know what you think. Thanks for watching. And I know I skipped a bit of details here and there because I don't know. Like I said, it's not super interesting for an interview. I don't know that it comes up that much. I mean, like for me as a nerd, like I'm a fan of knowing this stuff, but it's not. I don't know how practical it is. Leetcode just kind of been really silly lately with these kind of problems on contests. So I don't know. Anyway, though, thanks for watching. Stay good, stay healthy, to good mental health. I'll see you later. Take care. Bye bye.